Okay, it's time to do the internal bore now. And now looking at this here, the motor housing, it looks like that's shown about 1.68. So if I go 1.7, that should fit comfortably inside there. So I'll shoot for 1.7 right now on the internal bore to accommodate this right here. And again, the reason why I need to make the internal bore for this part to be a little bit smaller diameter is so that I have room down below here to put screws in when it comes time to put the handles and things on. Because I'm working with a very thin piece of stock here. I'm using 3 inches here, and that gives me a very, very thin edge here. And so I want to keep a lot of thickness down below here for the handles and things. Alright, that's coming up next. Okay, I have my gauge set up here so I can get my depth of cut. That's a little bit 1 inch over depth of cut with a 1/2 inch diameter drill bit. Just a little bit over 1 inch I went in. Now I'll use my 5/8 end mill and go in again another inch again and widen that hole a bit more now. Okay, now I'll go with my 3/4 inch end mill next. What I do is I take this all the way back, twist, taking going forward, touch off, and then I come back about 50 thou, and then lock the tailstock at 50 thousandths. Now I have 50 thousandths of an inch play here before I actually start touching into the actual workpiece. Right now my gauge is showing 0, and I'm now touching on. Hundred thousandths. And so on. 500 thousandths. 6. 91 inch. Let's see how far apart you can come from touching. If you feel more, if I start feeling tension, you're right there. Okay, about an inch and about 50 thousandths. Alright. There's the final depth of cut using the end mills. And just check it here for a... Alright, we're looking lower inch and about an inch and an eighth. That's what I'm looking for. That's all I can do with end mills. Now the next will be boring bars again, and keep on. And I need to bring this across about an inch and 3/4, all the way back that inch and an eighth, inch and a quarter or so. And now I got to find out what boring bars I'm going to use to do this. Alrighty, coming up next. Okay, I'm just nibbling away at about 20 or about 40 thousandths at a time, depth of cut, a little bit at a time. Take another 40. Off the diameter, 40 off the diameter. And so on. Okay, after about 12 years of using my lathe really heavy, the board finally went on it. Probably blew the MOSFET. I'm not sure what blew on it, but I looked on on the internet, littlemachineshop.com, and because my lathe is a 7x10 lathe, it's outdated. And so they discontinued the boards for the 7x10 mini lathe. So I'm in a little bit of a jam here, and I want to finish doing my project here on here. I got a few more jobs to do on the boring here to finish this out. So being that electronics is another one of my hobbies, I decided to throw together here a simple power supply, a variable voltage supply here, voltage regulator, an input of around 36 volts, filtered DC, and I gave myself a little bit of variable variation here that I can go down anywhere from between 19 and up to 36 volts on the output DC. And let me just show you what I got put together here real quick. Now this is just a quick put together so that I can continue doing machining, and once I get this done, the machining, then I'll put together a good supply. But it starts here. All I have now is wires connected to the switch right here. That's my switch to turn everything on. And from there, I have my wire clamped here. Follow that wire all the way down. And now I have all that going on. What I have here is, this would be the series pass transistor here, 2N3055. This over here is the series regulator. Not the regulator, but the series feedback circuit. A 12 volt Zener here, 12 volt, but I got a good fan on here to blow everything nice and cool here. Same here, nice fan. 12 volt Zener, half watt resistors, a variable resistor here to change the voltage output, 2 transformers, 13 volts each AC coming in, 26 volts coming out, After it goes to a bridge rectifier and filter, it comes out about 36 volts DC and then feeds into the regulator. I also have, like I said, I have a big fan here to keep everything cool here. I got a small fan here to keep the Zener cool. And what I'm doing is I'm keeping a voltage measurement that I can look at as I'm working here on my voltmeter here. I'll go ahead and plug this in now, and we'll see what we have here. Okay, right now I'm at 24 volts. I have the potentiometer here. I can turn this back and forth here. So I'm going to turn it down now to the left, all the way down. And I'm down around 17 volts now. Now I'm going to turn it up 18 volts, 19, and I can take this all the way up to 36 volts. Okay, what happened is my potentiometer came off here, the wire came off, and that's why I got a little erratic reading here. Okay, but we're now back in business here. I have it set now for about 25 volts, and I have my machine running. I'm going to turn the potentiometer here now down to its lowest value here and get it down to about about 17 volts. And it's going nice and slow now. And now let's take it up to 36 volts. Now 32 volts. It varies. It's a little bit faster now. Alright, we'll take it back down now to about 22, 23 volts. I'm going to work it at now. What's happening is this is an old potentiometer. It's probably not proper power rating. That's probably why I'm not getting full 36 volts. Okay, so I'll work it here now around 22, 23 volts here. Okay, so everything's working pretty good here now. And I'll start machining now. Alright, let's continue on. I'm at about 23 volts. As I put a load on here, I'm looking at my voltmeter and staying around 23 volts. It drops about 23.14. But it's staying steady at 23 volts. I'm pretty happy with that. So I'm not putting a real heavy load on there, but I am getting enough to cut. And during cutting operations here, I was putting a small load on there, but just keeping the voltage steady. Pretty steady over there. Good. Alright, let's continue on here. There's some 22 volts. It's going back up again. See, it's regulating. 23, it's regulating. That's good. It's regulating real good. Okay. Okay, let's take a measurement here. Okay, I'm going to increase the speed a little bit now. I'm going to take it to about 27 volts. It's taking about 40 thousandths at a time. Depth of cut. progress that's going on here. Just working a little bit at a time. I almost got the full width on the front side of that bottom hole. Now I'm working my way back from the bottom back out again and widening the whole thing a little bit at a time. I got enough room in there now to get a different boring bar in there now. It has a different bit on it now, a different bit geometry, so I can go almost back flat to the bottom of the hole now. Okay, let's take a look at it. Not bad. It looks pretty good. I'll keep on working that. I've got it down to about 19 volts right now, nice and slow. $30 thousandths to go yet. $30 thousandths. 10, 20, 30. Okay, now I'm doing the finish work. I'm facing off the back side now. I have my tool bit turned in a little bit so it's not rubbing. And I'm just now facing off the back side now, coming across the back side. Again, I have it on the lowest voltage I can get it on to keep the speed down as low as possible, so as to prevent any kind of chattering. Okay, the lathe work is done on this part here. We'll take it out of the lathe now and we'll check and see what it looks like now. Get it all cleaned up. Okay, here's what got done so far. Slides on there nice. Alright, that's all for right now. Next we need to put it on the mill now and start doing the drilling and things and get all the holes drilled using the indexing jig. That's coming up next.